four, three, two, one.
Ultimate Top 10. Number 1.
Recently, Google announced that it was shutting down its Glass Explorer program in an effort to refocus the project, and before long, we may have the new Google Glass 2. Regardless, Google Glass has already opened our minds to the possibilities of augmented reality. The basic idea of AR is to superimpose graphics, audio and other sensory enhancements over a real-world environment in real time. Applications for augmented reality are vast. The military uses AR to assist men and women making repairs in the field. The gaming industry has multiple uses for it with outdoor gaming. Navigation applications are possibly the most natural use of augmented reality in our everyday activities. Enhanced GPS systems are using augmented reality to make it easier to get around. Using AR devices or a phone's camera in combination with the GPS, users see the selected route over the live view of what is in front of them. There are a number of applications for augmented reality in the sightseeing and tourism industries. The ability to augment a live view of displays in a museum with facts and figures is a natural use of the technology. There have also been interesting advances in medical application of this technology. Medical students use the technology to practice surgery in a controlled environment.
Number 2.
3D printing is a process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object can be achieved using several processes. In an additive process, an object is created by laying down successive layers of material until the entire object is created. Each of these layers can be seen as a thinly sliced horizontal cross-section of the eventual object. Several projects and companies are making efforts to develop affordable 3D printers for home desktop use. Hewlett-Packard has unveiled a 3D printer that it claims will be 10 times faster than current models. The cost of 3D printers has decreased dramatically since about 2010, with machines that used to cost $20,000 now costing less than $1,000.
Number 3.
Scientist and inventor Nikola Tesla performed the first experiments in wireless power transmission at the turn of the 20th century and may have done more to popularize the idea than any other individual. Unlike Tesla's failed efforts at long-range wireless energy transfer, recent efforts focus only on short-range transfer via magnetic fields. We have seen wireless charging for gadgets, and that's proof enough to build a structure onto. A number of companies are trying to come up with electric hubs, which will be capable of powering up an entire house. The work is based upon the research done by Marin Soliachich of MIT, which is related in spirit to the work of Nikola Tesla but with significant differences. The idea is to make use of the fact that some particular electromagnetic waves make it easy to transfer energy, and electricity can be transferred between objects that are resonating at the same frequency. This technology is closer to reality than ever before.
Number 4.
The term artificial reality, coined by computer artist Myron Kruger, has been in use since the 1970s, and since then there has been an increase in interest in the potential social impact of virtual reality and all its applications. Although we can only imagine the future applications of virtual reality, it is in the gaming industry that we often see its most common use, with gadgets such as the Oculus Rift. The Oculus Rift is a new virtual reality headset that lets players step inside their favorite games and virtual worlds. The Rift uses custom tracking technology to provide ultra-low latency 360 degrees head tracking, allowing you to seamlessly look around the virtual world just as you would in real life. Every subtle movement of your head is tracked in real time, creating a natural and intuitive experience. Virtual reality is here to stay and evolve.
Number 5.
Artificial intelligence, AI, is in simple terms, the science of doing by computer, the things that people can do. Over recent years, artificial intelligence has advanced significantly. Most of us use smartphones that can recognize human speech or have traveled through an airport immigration queue using image recognition technology. Self-driving cars and automated flying drones are now in the testing stage before anticipated widespread use, and for certain learning and memory tasks machines now outperform humans. Artificial intelligence, in contrast to normal hardware and software, enables a machine to perceive and respond to its changing environment. Emergent AI takes this a step further, with progress arising from machines that learn automatically by assimilating large volumes of information.
Number 6.
The race is on, for all the car manufacturers set on building a driverless car, such as Mercedes-Benz, BMW and Audi. Leading the race is undoubtedly Google, seeing that software is the biggest obstacle for all others. While the data source is still a secret recipe, the Google driverless car is powered by artificial intelligence that utilizes the input from the video cameras inside the car, a sensor on the vehicle's top, and some radar and position sensors attached to different positions of the car. Sounds like a lot of effort to mimic the human intelligence, but so far the system has successfully driven 1,609 kilometers without human commands. Sooner rather than later, some sci-fi movie scenes will be a reality.
Number 7.
In the near future, digital currencies, including cryptocurrencies, will thrive. Governments are exploring frameworks and systems to regulate and manage digital currencies, which will make their ubiquity in our everyday financial vernacular more profound. Ecuador's Congress recently approved a reform to create a digital currency, and the New York State Department of Financial Services is considering establishing virtual currency exchanges. The UK government is calling for information about the benefits and risks of digital currencies. We can expect digital currencies to be used interchangeably with legal tender, giving birth to a frictionless and agile universal payment system that will expand beyond the current banking ecosystem.
Number 8.
Leap Motion is a small USB controller which uses 2 infrared cameras and 3 infrared LEDs to translate the motions of your hands into input for applications. The LEDs generate a 3D pattern of dots of infrared light and the cameras generate almost 300 frames per second of reflected data, which is then sent through a USB cable to the host computer. Although popular opinion is that Leap Motion right now is more of a toy than a productivity tool, it surely has its use and major potential to play a significant role in the future of our interaction with devices.
Number 9.
The future holds holographic television, instead of your LEDs or extra HD TVs. The next generation of TV won't be about the screen size and quality, but rather about viewing area. MIT researchers have created a chip which is able to render a holographic display as good as real-world, 50 gigapixels per second. The cost of such TVs would be too high, that's the general opinion. But Michael Bove, MIT's head of Object-Based Media Group, disagrees.
The technology itself is one that's easy and inexpensive and, as far as we are aware and nature is aware, has never been applied to displays before.
According to his speculations, such TVs will be available in the next 10 years or so.
Number 10.
Samsung Electronics has developed a new way of transmitting Wi-Fi data, 5 times faster than was previously possible. The new technology is expected to be available in consumer devices as early as 2015. If you've been to a cafe or other public place recently and been frustrated at the slow speed of Wi-Fi, a new breakthrough by Samsung may soon change that. Researchers at the company have achieved the development of 60 GHz Wi-Fi, allowing transfer rates of 4.6 gigabits per second, or 575 megabytes per second. That is 5.3 times faster than the previous maximum speed for consumer devices, 866 megabits per second, or 108 megabytes per second. Today's generation of Wi-Fi uses the 2.4 GHz and 5 GHz areas of the radio spectrum. The 60 GHz band is currently unlicensed and offers major potential, but previous attempts to exploit it have failed to send data over significant distances due to path loss and weak penetration properties. Samsung has overcome these issues through a combination of millimeter wave circuit design, a high-performance modem and wide coverage beamforming antenna. This eliminates co-channel interference, regardless of the number of devices using the same network. To give you an idea of the speed, a 1 GB movie will take less than 3 seconds to transfer between devices, while uncompressed high-definition videos could easily be streamed from mobile devices to TVs in real time without any delay. Commercialization is expected in 2015, with Samsung planning integration into a wide variety of products, including audio-visual, medical devices and telecommunications equipment.
Thank you for watching. Please subscribe.